Hey students, today's lesson is on solving multi-step equations. Let's start with some examples. We have negative 3x plus 5 equals 2. So notice we have two terms on this side of the equation and only one term over here. We have constants on both sides of the equation, and we have a term that contains our variable x only on the left. So our goal is to get x by itself. So let's start by moving all of the constants to the right side of the equation. So we're going to combine like terms by subtracting 5 or adding negative 5 to both sides of the equation. When we do that, we're left with negative 3x on the left, and that's equal to 2 minus 5, or 2 plus negative 5, which is negative 3. Now we're down to a one-step equation with multiplication. We'll solve it by dividing by negative 3. And we're left with x equals 1. Now we can go ahead and check our solution by putting 1 back into the equation. So we'll say negative 3 times 1 plus 5 equals 2. We'll simplify by having negative 3 plus 5 equals 2. And that is true. 2 equals 2. So we got it. Let's go ahead and look at the next equation. Again, we have two constant terms and one term that contains x. So let's add 1/2 to both sides to combine our like terms of constants. That leaves us with x over 8 equals, let's think, negative 7/2 plus 1/2 is negative 6/2, which is negative 3. So x over 8 equals negative 3. Now we're down to a one-step equation that we're going to solve by multiplying both sides by 8. And we get x equals negative 24. Let's go ahead and check our solution by putting negative 24 back into our equation. Negative 24 over 8 minus 1/2 equals negative 7/2. We can reduce this negative 24 over 8 by dividing both by 4, the numerator and the denominator. So we have negative 6/2 minus 1/2 equals negative 7/2. That gives us negative 7/2 equals negative 7/2. So we got it. All right, let's look at our next example. This time we're going to combine like terms before solving. So when we look, we have two terms on the left side of the equation that both contain the variable y. So we can combine our like terms. I'm going to rewrite this as addition. So 3y plus negative 8y equals 25. That helps me combine my two terms that contain y. So I have negative 5y equals 25. And then I'm going to divide both sides by negative 5 and get y equals negative 5. Let's go ahead and check our solution by putting negative 5 back into our original equation in place of y. So we have 3 times negative 5 minus 8 times negative 5 equals 25. So let's do our multiplication first. 3 times negative 5 is negative 15 minus negative 40 equals 25. Now I'm going to rewrite my subtraction as addition. Negative 15 plus the opposite of negative 40, which is positive 40, equals 25. Now I have a positive and negative, so I'm going to subtract their absolute values. 25 equals 25. We got it. All right, moving right along. Here we have a few examples that have variables on both sides of the equation. Okay, so here we have 15 minus 2x equals negative 7x. So our goal is still to get x by itself. That means we're going to need to combine our terms that have x in them, and we'll do that by adding 2x to both sides. That'll make it so that we don't have an x term on the left side, but only on the right side of the equation. All right, now I'm left on the left with 15, and that's equal to negative 7x plus 2x would be negative 5x. Now I just have a simple one-step equation left. Divide by negative 5, and I get x equals negative 3. Let's go ahead and check our work. 15 minus 2 times negative 3 equals negative 7 times negative 3. Let's do our multiplication first. So we have 15 minus negative 6 equals negative times negative is positive 21. That's 15 plus the opposite of negative 6, so 15 plus 6 equals 21. 21 equals 21. So we're good with that one. Let's go ahead and try this example. This time, not only do we have a variable on both sides, we also need to distribute. And we also have some subtraction. So let's start by changing our subtraction to addition, and we'll go from there. So we have negative 2 times x plus negative 5 equals, let's do the same thing on the right, 6 times 2 plus negative 1/2 x. All right, now let's do our distributing. So negative 2 times x is negative 2x plus negative 2 times negative 5 is positive 10. That's equal to 6 times 2 is 12 plus 6 times negative 1/2 x would be negative 3x. Okay, so we have negative 2x plus 10 equals 12 plus negative 3x. So now we still have an equation that has variables on both sides of the equation. Let's get the variables all on one side so that we can solve. Let's do that by adding 3x to both sides. When we do that, we have negative 2x plus 3x is just 1x, or x. So x plus 10 equals 12. And now we're to a one-step equation that we could solve by subtracting 10 from both sides, and we get x equals 2. All right, let me move. Oh, no, I can't move it down. Okay, we'll go ahead and do our quick check here. So negative 2 times 2 minus 5 equals 6 times 2 minus 1/2 times 2. Let's simplify what's inside the parentheses first. We could distribute, but since we're working with just numbers now instead of variables, we might as well simplify. So negative 2 times negative 3 equals 6 times 2 minus 1. Negative 2 times negative 3 is positive 6, and that equals 6 times 1. So yeah, 6 equals 6. We've got it. All right. Just 2 more examples here. I'm going to show you an example of an equation that has no solutions. So here we have 3 minus 4x equals negative 7 minus 4x. So again, we have variables on both sides of the equation. But look what happens when we try to combine our like terms. We'll add 4x to the left and to the right, and we have 3 equals negative 7. Well, 3 does not equal negative 7, and there's nothing we can do to make 3 equal to negative 7. So it doesn't matter what x is. This is not an equation that has any solutions. So you're just going to write no solutions. If the equivalent equation is never true, the equation has no solutions. On the other hand, sometimes you're going to see equations that have infinitely many solutions. In other words, It doesn't matter what you put in for x, it's always going to be true. So let's try this. We have x on both sides of the equation, but we also need to distribute. So we'll rewrite this 6x plus 4. And then 4 times 3 halves x, that would be 12 over 2, or 6x, plus 4 times 1. Now, we still have an equation with a variable on both sides, so when we try to combine our variable terms, we'll subtract 6x from both sides, and we get 4 equals 4. Once we see that, we know it doesn't matter what x is, this equation is going to be true. There are infinitely many solutions. So what we usually write for that is all real solutions. Or in other words, any real number is going to work for this. And that's all we're working with this year is real numbers. So we're going to go ahead and close there. Go ahead and try a few on your own, and I will see you soon.